Hey, welcome to my YouTube channel, Fun Online Maths. Today we'll be looking at this question on the board, and for more videos like this, mathematical questions, do also like, comment, and follow me at Fun Maths. Okay, the question says find the exact values of k such that the straight line y equals to 1 minus k minus x is a tangent to this curve. Now, this is the solution. I'm going to move to this side. The equation of a straight line is given as y equals to mx plus c. Okay, now from this question, this is the straight line equation we are given, y equals to 1 minus k minus x. Now I'm going to rewrite it so that I have x first, then the constant terms. So it means that y will be equals to minus x, then plus 1 minus k. Now, if you compare this particular equation with this equation, you discover that this has minus x and this has mx, and then m is equals to the coefficient of x here is minus 1. There's an invisible 1 there, so that's m equals to minus 1. This is called the slope. Okay, this is called the slope. You can also call it the gradient. So I'm going to call that the slope. Now coming back here, this is a tangent to the curve ks squared plus s plus 2k. So I'm going to rewrite that y equals to kx squared plus x plus 2k. Now for this particular one, what we are going to do is differentiate. If we differentiate this, we'll be able to get this curve also. The first derivative, it's going to give us the slope. The first derivative is the slope. Change in y over change in x. So that's dy dx is equals to differentiating y with respect to the x here is equals to these two. Now please take note, if you have y equals to x raised to power n and you are differentiating, the y dx is equals to the n coming before the x, and then we have xn minus 1. So this is how we differentiate. I'm going to use that principle here. The 2 is going to come before k. 2k, k is the constant. So 2k x raised to power 2 minus 1, which is 1. There's no need to write that. Plus, if you differentiate x, this is the power is just 1. So it becomes 1 x raised to power 1 minus 1, right? 1 minus 1 is 0. And there's no need to write 1 here. Then plus 2k. Now when you differentiate a constant term, it's going to return 0. So everything here is going to be 0. So this is our, okay, let me rewrite this. 2kx, anything to the power of 0 is 1, so plus 1. So I have this slope. This is also a slope. Okay, so I'm going to be equating the both of them. Now we have 2kx, we have 2kx plus 1. I said this is a slope as also this. So this is equals to minus 1. Collect like terms, 2kx will be equals to minus 1. Then the plus minus move to this side becomes minus 1. And then we have 2kx equals to minus 2. I want to get x from this particular problem. So I'm going to divide both sides by 2k, and then this goes with this. X will be equals to this will cancel this, minus 1 over k. Okay, so that's for x. Now coming back to the equation, we have been given two equations, the equation of a straight line and the tangent to this is the curve. So coming back there, I'm going to replace x with minus 1 over k for each of them. For the first one, for equation 1, y equals to 1 minus k minus x. Please take note, this is what I'm looking at. X is now minus 1 over k. So y is equals to 1 minus k. Minus times minus is going to be plus 1 over k. And now we can say let k is the LCM. So y is equals to k being the LCM. The denominator here is 1, denominator here is 1. K divided by 1 is k times 1. That's going to be k minus k divided by 1 is k times k is k squared plus k divided by 1. itself, sorry, is 1. 1 times 1 is 1. So this is for, let's call this equation. We have been doing a lot of equations. So let's call this 1 since we've not named anyone. So that's for this. While for this particular one, y is equals to kx squared plus x plus 2k. Okay, now I said I'm going to be replacing x with minus 1 over k. So y is equals to k into minus 1 over k squared plus minus 1 over k plus 2k. Okay, so y equals to minus 1 over k is the same thing as k into minus 1 square over k square, right? And minus 1 square is 1 over k square. Plus minus is minus, that's minus 1 over k plus 2k. So this particular k removes one of the k here. It has 2 k's. So it removes one of them. We're left with y equals to 1 over k minus 1 over k plus 2k. And then since these two are the same, they cancel out, y will be equals to 2k. So now what I'm going to do is, I call this equation 1, right? I'm going to call this 2. What I'm going to do is to equate this equation to this. Okay, the both of them are the values of y. We already have the value of x, so let's equate the both of them, their y's. So k minus k squared plus 1 over k is equals to 2k. Okay, now what I'm going to do is to cross multiply. So k minus k squared plus 1 will be equals to 2k times k, which is 2k squared. We'll collect like terms, and in fact I want to move everything to a particular side, and I'll be having 2k squared. Then this moves to the right hand side, minus becomes plus k squared minus k, then minus 1 equals to 0. 2k squared plus k squared, the coefficient here is 1, so 2 plus 1 is 3, so this is 3k squared minus k minus 1 equals to 0. So now we're going to be using almighty formula just to get the values of k. Okay, so we have 3k squared minus k minus 1. The almighty formula is given as minus b plus minus the square root of b squared minus 4ac over 2a. In this case, everything here is equals to k. Okay, so the a here is the coefficient of k squared, which is 3. B is the coefficient of k, is minus 1, and c is the one we have here, minus 1. Now this can be written as minus b, which is minus 1 plus minus the square root of b squared minus 1 square minus 4 times a is 3 times c is minus 1 over 2a, 2 times 3. And everything here is equals to k. You can either write it here or write it here. And then this is minus times minus 1 plus minus the square root of 1 minus 1 square is 1 minus 4 times 3 is 12 times minus 1, that is minus 12. Minus 12 times minus, that's going to be plus 12 over 2 times 3 is 6. So this is, let's say this is equals to k. K equals to 1 plus minus the square root of 13 over 6. And this is going to be two values. K is equals to either 1 plus this root of 13 over 6, or k is equals to 1 minus the root of 13 over 6. These are going to be our answers. You can break it further than that, but I'm going to stop here for now. This is my final answer. Please do well to like, share, and follow me at Fun Online Maths for more videos. It's goodbye from me. Subscribe to this YouTube channel. Bye bye.